Over the past 40 years, humanity has poured more concrete than in all of recorded history combined. In just 3 years, China used more cement than the United States consumed throughout the entire 20th century. Cement alone accounts for nearly 8% of global CO2 emissions, yet it's still treated as a symbol of progress. The newer a city is, the more concrete it has, and the more likely it is to flood, overheat, and sink. If concrete was meant to protect cities, why is it now helping them fail faster than ever? In July 2021, a newly upgraded subway station in Zhengzhou filled with water in minutes. The city had poured billions into concrete flood defenses. Roads were sealed, rivers were straightened, drainage channels were buried. When the rain came, the water had nowhere to go. 14 people died underground. The station was modern. The system worked exactly as designed. In Houston, after Hurricane Harvey, engineers found the same pattern. Decades of concrete expansion had replaced wetlands that once absorbed floodwater. Over $125 billion in damage followed. The city didn't lack money. It lacked ground that could breathe. In Jakarta, the problem isn't rain. It's weight. Concrete towers, highways, and ports press down on soft soil while groundwater is pumped out to support construction. Parts of the city sink by more than 10 centimeters a year. Sea walls rise. The ground keeps falling. In Europe, cities like Paris and London are discovering a quieter failure. Heat waves now linger longer in concrete-heavy districts. Nighttime temperatures stay high. Deaths rise not from storms, but from heat trapped between stone and asphalt. Everywhere the story looks different. Floods, heat, collapse, death. But the pattern is the same. Cities keep adding concrete to solve problems created by concrete. The fixes grow larger. The failures follow. If these disasters aren't accidents, and the material is doing exactly what it was built to do, then what kind of system keeps choosing the same solution, no matter the cost? Concrete is everywhere, but its scale is easy to miss. Every year, the world produces more than 4 billion tons of cement. That's enough to pour a layer of concrete over the entire city of London every few weeks. Cement alone is responsible for roughly 8% of global CO2 emissions, more than the entire aviation industry. And unlike planes or cars, concrete emissions are locked in the moment it's made. Once poured, the carbon is already spent. China reshaped the planet faster than any country in history. Between 2011 and 2013, it consumed more cement than the United States did in the whole 20th century. Entire cities appeared almost overnight. Highways, bridges, apartment blocks, flood barriers. Growth was measured in square meters of concrete poured per year. GDP rose. Risk accumulated quietly underneath. India is following a similar path. Cement demand is projected to double within 2 decades as hundreds of millions move into cities. New expressways cut through floodplains. Rivers are narrowed or lined with concrete walls. What looks like control on paper becomes rigidity in reality. In the Middle East, concrete means survival against heat. Glass and reinforced cement dominate skylines in Dubai, Doha, and Riyadh. But as urban density increases, surface temperatures rise faster than surrounding deserts. In some districts, nighttime temperatures remain dangerously high, trapping heat between buildings and asphalt. Cooling demand surges. Power grids strain. Cities pour more concrete to expand infrastructure, which in turn worsens the heat they are trying to escape. Europe presents a different illusion. Growth is slower, but the legacy is heavier. Cities built over centuries now sit on sealed ground. In Germany, France, and the UK, more than half of urban land is covered by impermeable surfaces. Rainfall that once soaked into soil now rushes into drains designed for a different climate. Flood damage across Europe has multiplied over the last 3 decades, not because cities grew faster, but because they hardened. In the United States, concrete became a financial instrument. Highways unlocked suburbs. Suburbs unlocked mortgages. Mortgages fueled growth. From parking lots to interstates, concrete spread as a promise of prosperity. But maintenance costs now exceed what many cities can afford. Roads crack. Bridges age. Drainage systems fail. Municipal debt rises as cities borrow just to keep concrete from collapsing. Globally, urban land area is expected to triple by mid-century. Most of that expansion will be built the same way. poured fast, standardized, and sealed. The math is simple. More concrete means less absorbent land. Less absorbent land means faster floods, higher heat, and deeper reliance on engineered fixes. Yet concrete remains politically invisible. It creates jobs. It shows results quickly. A bridge can be photographed. A highway can be opened before an election. The costs, heat deaths, flood risk, subsidence, long-term debt, arrive later, often after responsibility has shifted. This is why concrete keeps winning. It turns complex environmental problems into construction projects. It converts uncertainty into contracts. And it allows cities to grow without confronting limits. But when a material is poured at this scale, across this many climates, under this much pressure, it stops being just a building choice. It becomes a system. One that reshapes water, heat, land, and money all at once. If concrete is no longer just a material, but the backbone of how cities expand, then the real question isn't how much we build, but why this system cannot stop building, even when the risks are already visible. Concrete was designed to solve uncertainty. It hardens fast. It stays in place. It resists movement. That's why cities trust it. And that's exactly where the paradox begins. A city survives by letting water move. Rain must soak into soil, spread, slow down, evaporate, or drain naturally. Concrete does the opposite. It seals the ground. It turns land into a hard lid. When rain falls on concrete, almost all of it becomes runoff. In natural ground, up to half of rainfall can be absorbed. On concrete, absorption drops close to zero. That single property reshapes everything. Floodwater arrives faster. Drains overload sooner. Rivers peak higher. Cities respond by pouring more concrete. Wider channels, higher walls, deeper tunnels. Each fix removes more absorbent land, making the next flood sharper than the last. Heat follows the same logic. Concrete absorbs heat during the day and releases it slowly at night. In dense cities, this traps warmth long after the sun sets. In Tokyo, summer nighttime temperatures in concrete-heavy districts can stay 5 to 7 degrees Celsius higher than nearby rural areas. In Paris, heat waves now kill more people than floods. The buildings that were meant to protect residents lock heat in instead. Then there's weight. Concrete is heavy. Very heavy. A single square meter of reinforced concrete can weigh over 2 tons. When cities stack it, roads, towers, subways, they compress the ground beneath them. In places like Jakarta, Bangkok, and parts of Mexico City, this weight combines with groundwater extraction, causing land to sink. Some neighborhoods drop several centimeters every year. Sea walls rise. The ground keeps falling. The paradox is that concrete is stable, but cities are not. Cities are living systems. Water levels change. Temperatures swing. Soil shifts. Climate patterns move. Concrete resists all of that. It locks cities into one shape, one assumption, one climate that no longer exists. Engineers know this. Urban planners know this. The data is not secret. Permeable surfaces reduce flood risk. Green space cools cities. Flexible land absorbs shocks. But those solutions are slow, messy, and hard to measure. Concrete is fast. It photographs well. It shows progress immediately. So cities keep choosing rigidity over resilience. There's another layer to the paradox. Scale. Concrete works well in small amounts. A foundation, a bridge, a retaining wall. Problems appear when it becomes the default for everything. When entire watersheds are paved. When rivers are straightened and lined. When soil is treated as a liability instead of an asset. At that scale, concrete doesn't just support cities. It rewires them. Drainage systems become the only way water can move. Cooling systems become the only way heat can escape. Maintenance becomes permanent. Failure becomes systemic. A clogged drain floods a district. A power outage during a heat wave turns buildings into ovens. And once a city is built this way, it cannot easily reverse course. You can't unpour concrete. You can't cheaply remove highways. You can't quickly restore soil that's been sealed for decades. Every fix becomes another layer on top of the last mistake. This is why concrete creates dependence. The more a city pours, the more it must keep pouring just to function. Not to improve, to survive. The paradox is complete when concrete is used to fight the very disasters it amplifies. Sea walls against rising oceans. Flood channels against sealed ground. Cooling infrastructure against heat islands. Each solution treats the symptom, not the structure. Concrete doesn't fail because it's poorly made. It fails because it works exactly as intended, rigid, sealed, unmoving, in a world that no longer is. And if the core problem isn't bad construction, but a system that keeps choosing rigidity in a changing climate, then what kind of machine keeps cities locked into the same material, even as the risks become impossible to ignore? Concrete doesn't spread on its own. It moves through a machine. A quiet one. Once it starts, it's hard to step out. At the center of that machine is speed. Concrete is fast money. A road can be approved, poured, and opened within a political cycle. A flood barrier looks like action. A housing block looks like progress. Soil restoration takes years. Wetlands don't cut ribbons. Concrete does. This is why governments favor it. Infrastructure spending boosts GDP immediately. In many countries, construction accounts for 6 to 10% of national output. In China, during peak years, it climbed even higher. Growth became measurable in cubic meters poured. When growth slows, the solution is simple. Build more. Then come the companies. Cement production is capital-intensive and concentrated. A handful of firms dominate regional markets. Once a plant is built, it must run near full capacity for decades to stay profitable. Idle kills bleed money. So supply pushes demand. New projects appear not because cities need them, but because plants cannot stop producing. Public procurement locks this in. Governments don't buy resilience. They buy projects. Roads, bridges, tunnels, seawalls. Each one requires standardized materials, predictable timelines, and clear budgets. Concrete fits perfectly. Green alternatives are labeled experimental, risky, or slow. In bidding documents, flexibility becomes a liability. Finance completes the loop. Large concrete projects are easy to finance because they look tangible. Banks prefer assets they can value, insure, and collateralize. A highway has a price tag. A restored floodplain does not. Municipal bonds fund expansion. Debt is justified by future growth. Growth depends on more construction. The cycle feeds itself. Real estate accelerates everything. Concrete turns land into units. Units into sales. Sales into loans. In cities from New York to Shanghai, property value is directly tied to built density. More floors mean more revenue. Developers push upward and outward. The ground below becomes an afterthought. This machine doesn't ask whether concrete is the right solution. It asks whether it is the fastest one. Maintenance keeps the system running long after the benefits fade. Concrete ages. Cracks spread. Rebar corrodes. Bridges built in the 1960s and 70s now require constant repair. In the United States alone, the maintenance backlog for roads and bridges runs into the trillions of dollars. Cities borrow not to expand, but to stop collapse. And still they pour more. Disasters reinforce the machine instead of breaking it. After floods, the response is higher walls. After heat waves, more cooling infrastructure. After subsidence, thicker foundations. Each crisis justifies another round of construction. Emergency budgets bypass scrutiny. Speed matters more than redesign. In some countries, corruption seeps in. Concrete becomes a vehicle for rent extraction. Overpriced contracts. Ghost projects. Inflated volumes. In others, the process is legal but no less binding. Lobbying ensures building codes favor conventional materials. Innovation is boxed out by regulation. Even climate policy struggles to escape this logic. Cement emissions are acknowledged, but rarely constrained. Cutting production threatens jobs, housing targets, and growth forecasts. So the industry promises efficiency gains instead. Marginal improvements. Cleaner kills. Carbon capture sometime in the future. Meanwhile, total volume keeps rising. The machine thrives on fragmentation. Engineers handle drainage. Architects handle buildings. Transport agencies handle roads. Climate risk sits somewhere else. No one owns the whole system. Each part optimizes locally. The result is global rigidity. Once concrete is poured, it shapes decisions for generations. A highway fixes traffic patterns. A flood channel locks water into one path. A sealed district cannot suddenly become absorbent when rainfall changes. Cities inherit yesterday's assumptions in solid form. And there is no pause button. Stopping construction threatens employment, growth, political credibility. Leaders who hesitate risk backlash. So they keep building, even when they know the ground is sinking, the water is rising, and the heat is climbing. This is the invisible machine. Not a conspiracy. Not a single villain. A set of incentives aligned so tightly that alternatives barely register. Concrete isn't chosen because it's best. It's chosen because everything else is harder to finance, slower to justify, and less visible. Once a city enters this system, leaving it feels impossible. Every solution looks like another layer. Every delay looks like failure. The machine doesn't ask whether cities should keep pouring concrete. It assumes they must. And if this machine keeps cities locked into building the same way, even as floods deepen, heat intensifies, and land sinks, then what happens when its consequences finally become too large to reinforce with concrete itself? The damage doesn't arrive the same way everywhere. Concrete adapts to local conditions. But the outcome is consistent. Cities harden. Nature is pushed out. Failure changes shape, not direction. In South Asia, floods arrive fast and violent. In India, rapid urban expansion has replaced floodplains with roads, malls, and apartment blocks. In cities like Chennai and Bengaluru, lakes that once absorbed monsoon rain were filled or walled off. In 2015, Chennai flooded after days of rain. Water had nowhere to spread. Losses exceeded $3 billion. Just 4 years later, the same city faced a water crisis so severe that reservoirs ran dry. Concrete caused both extremes. Too much water, then none. In Southeast Asia, subsidence is the quiet killer. Jakarta is sinking faster than almost any major city on Earth. In some northern districts, land drops more than 10 centimeters a year. The reasons are layered: groundwater extraction, soft soil, and massive concrete load from highways, ports, and high-rise developments. Sea walls are built higher every decade. But the city keeps sinking behind them. By mid-century, parts of Jakarta are expected to sit below sea level permanently. Bangkok follows a similar pattern. Concrete expansion and heavy buildings compress the ground while canals are filled or narrowed. Flood protection relies on pumps and barriers. When power fails or rainfall exceeds capacity, water rushes in. The city becomes dependent on constant energy just to stay dry. In the Middle East, heat is the battlefield. Cities like Dubai and Riyadh rely on concrete and glass to grow vertically in extreme climates. But these materials trap heat. In dense districts, surface temperatures soar. Air conditioning becomes essential, not optional. Cooling demand consumes vast amounts of electricity, much of it generated from fossil fuels. Heat feeds power use. Power feeds emissions. Emissions intensify heat. Concrete sits at the center of the loop. During recent heat waves, nighttime temperatures in parts of the Gulf remained above levels considered safe for human recovery. The danger isn't just the daytime peak. It's that bodies never cool down. Concrete holds the heat and releases it slowly, turning entire neighborhoods into thermal storage units. In Europe, the damage looks subtler but spreads wider. Cities like Paris, Cologne, and Milan were built long before modern climate shifts. Over time, streets were paved, courtyards sealed, rivers straightened. Today, more than half of urban land in many European countries is impermeable. When heavy rain hits, drainage systems built decades ago are overwhelmed. Flood damage across Europe has multiplied in recent decades. Even where rainfall hasn't increased dramatically, the land simply can't absorb shocks anymore. Heat waves reveal another layer. In 2003, tens of thousands died across Europe during extreme heat. Many deaths occurred in dense, concrete-heavy neighborhoods where temperatures stayed high overnight. Since then, cities have added green roofs and shade in limited areas. but the underlying structure remains sealed. In North America, concrete failure is financial as much as physical. Suburban expansion covered vast areas with roads, parking lots, and low-density housing. Infrastructure stretched outward faster than tax bases could support. Maintenance costs now overwhelm municipal budgets. Bridges built during post-war booms age at the same time. Drainage systems designed for smaller storms face heavier rainfall. Cities borrow to repair what they already built, while new development continues at the edge. After Hurricane Harvey, Houston became a case study. Wetlands had been replaced by concrete subdivisions. Rainfall totals were extreme, but the scale of flooding was amplified. By land use, billions were spent on recovery. New flood control projects followed. More concrete was poured. The underlying pattern remained unchanged. In Latin America, informal settlements collide with formal concrete expansion. In cities like Sao Paulo and Mexico City, rapid construction pushes low-income communities into flood-prone zones. Hillsides are stabilized with concrete walls. Rivers are channelized. When systems fail, the poorest areas absorb the impact. Landslides, flash floods, infrastructure collapse. Concrete protects wealthier districts while concentrating risk elsewhere. Across Africa, the pattern is emerging fast. New highways, ports, and urban developments promise growth. But many are built without integrated water management. Coastal cities face rising seas while sealing land inland. When floods hit, recovery resources are limited. Each new concrete project increases exposure. The map looks different on the surface. Floods here, heat there, subsidence somewhere else, debt everywhere. But the structure is shared. Concrete removes flexibility. It forces cities to rely on engineered control rather than natural buffering. When climate variability increases, control systems must be larger, faster, and more expensive. Failure becomes binary. Systems work until they don't. Then damage is sudden and widespread. What makes this destruction harder to see is timing. Concrete problems compound slowly. A sealed parking lot doesn't flood the city on its own. A single tower doesn't cause subsidence. A widened channel doesn't overheat a district overnight. But layer by layer, city by city, the same logic repeats. Each region believes its case is unique. Each response is local. But when you zoom out, the pattern becomes impossible to ignore. The same material, the same incentives, the same outcomes. This is not a future scenario. It's already mapped in losses, deaths, and repair bills across continents. Concrete hasn't just reshaped cities. It has synchronized their vulnerabilities. And if this damage keeps spreading differently but predictably across the world, then the next question isn't where the next failure will happen, but when a single disaster finally exposes how fragile the entire system has become. The breaking point rarely looks dramatic at first. It arrives on a normal day, inside systems that were declared complete. On July 20th, 2021, Zhengzhou recorded more than 600 millimeters of rain in 3 days. In 1 hour, rainfall exceeded what the city was designed to handle in an entire year. The flood defenses were new. The tunnels were modern. The concrete was fresh. When water poured in, it didn't seep. It rushed. Subway tunnels filled in minutes. Trains stopped between stations. 14 people died underground. Rescue teams found no structural failure. The system worked exactly as engineered. It just had no margin. Zhengzhou was not poor. Billions had been spent on drainage upgrades, widened channels, and reinforced embankments. The city had sealed its ground to control water. When the rain arrived, control became acceleration. Water had only one direction left. 2 years earlier, Venice experienced its own moment of collapse. In November 2019, the city flooded under Acqua Alta levels not seen in half a century. Sea barriers were still incomplete. Streets turned into canals. Shops were destroyed. Residents waded through saltwater inside historic buildings. Venice had invested heavily in concrete barriers to hold the sea back. But the city itself had been sinking for decades under its own weight, while sea levels rose. Protection arrived late, rigid, and incomplete. In Jakarta, the crisis is slower but more certain. The city sinks every year. In some neighborhoods, Streets are repaved repeatedly as the ground drops beneath them. Houses tilt. Cracks spread. Sea walls rise higher. The government announces plans to move the capital. Meanwhile, concrete towers continue to go up. Ports expand. Highways are reinforced. Each layer adds weight to soil already collapsing. The fix deepens the cause. In Houston, the collapse is measured in dollars. Hurricane Harvey didn't break levees. It overwhelmed them. Over $125 billion in damage followed. Engineers later mapped flood patterns and found that development had pushed water into neighborhoods never meant to absorb it. Wetlands that once slowed storms had been replaced by subdivisions, parking lots, and roads. After the flood, rebuilding poured even more concrete into the same zones. The city promised resilience. The footprint stayed the same. In Germany's Ahr Valley, July 2021 floods killed over 180 people. Small rivers rose meters within hours. Concrete channels sped water through towns faster than evacuation could keep up. Villages built to manage normal flows were erased by extreme ones. Investigations found no single failure. Warnings existed. Models existed. Infrastructure existed. The scale had changed. The rigidity remained. Heat delivers its own climax. During Europe's recent heat waves, deaths climbed quietly. Many occurred at night, when bodies failed to cool. Dense, concrete-heavy neighborhoods retained heat long after sunset. Air conditioning helped those who had it. Others opened windows to air that never cooled. Hospitals filled. Power grids strained. There was no collapse moment, just exhaustion and silence. These events aren't outliers. They are thresholds being crossed. What links them isn't rain, or sea level, or temperature. It's how little room cities have left to absorb change. Concrete removes buffers. It converts gradual stress into sudden failure. When systems reach their limit, they don't bend. They snap. The human cost concentrates where flexibility is lowest. Underground stations. Basement apartments. Informal housing near channels and walls. People die where water accelerates and heat traps. Not because cities ignored risk, but because they engineered it out of sight. After each disaster, the response looks familiar. More barriers. Deeper tunnels. Thicker foundations. Larger budgets. Emergency powers speed approvals. Construction accelerates. The same machine activates, now fueled by urgency. Politicians promise protection. Engineers promise upgrades. Developers promise safer designs. The material stays the same. The footprint grows. The most revealing moment often comes after the cameras leave. Insurance payouts stall. Repair costs exceed estimates. Cities borrow to rebuild. Maintenance schedules stretch. Temporary fixes become permanent. The burden shifts forward in time. Concrete doesn't fail suddenly. It fails cumulatively. Each project reduces options. Each repair commits cities to higher maintenance. Each barrier assumes yesterday's climate. When tomorrow arrives faster, there's no space to adjust. At the climax, cities face a choice they rarely acknowledge. Keep reinforcing rigidity, or accept that the foundation itself is part of the problem. One path is visible, funded, and familiar. The other requires undoing, slowing down, and redesigning systems that entire economies depend on. So far, almost everywhere, the decision is the same. Cities respond to concrete-driven disasters by pouring more concrete. They mistake strength for resilience. They treat symptoms as causes. And with every cycle, the margin shrinks. If the most catastrophic failures are happening not because cities lacked infrastructure, but because they had too much of the wrong kind, then what happens when the next shock exceeds even reinforced limits, and there's nothing left to harden without breaking everything beneath it? Collapse doesn't arrive as one final event. It spreads. Slowly. Quietly. And by the time it's visible, reversing it is no longer an option. The first thing to fail is maintenance. Concrete cities are expensive to keep alive. Roads crack. Bridges corrode. Drainage systems clog. Heat weakens surfaces faster than expected. In many countries, infrastructure built during growth booms is now aging at the same time. In the United States, The estimated backlog for basic infrastructure repair runs into the trillions of dollars. Cities borrow just to keep systems functioning at yesterday's level. Expansion pauses. Repair becomes permanent. As costs rise, flexibility disappears. Budgets tighten. Emergency funds replace planning. Short-term fixes dominate long-term design. Drainage pipes are widened instead of land being reopened. Cooling systems are added instead of shade being restored. Each decision locks the city further into concrete dependence. Then comes insurance retreat. Flood risk maps are updated. Premiums rise. Coverage shrinks. In coastal and flood-prone cities, insurers quietly pull back. Some neighborhoods become uninsurable. Property values stall or fall. Mortgages become harder to secure. What was once a growth engine turns into a liability. When insurance leaves, governments step in. Public funds replace private risk. Disaster relief becomes routine. Budgets shift from development to recovery. Taxes rise or services are cut. The financial burden spreads beyond affected zones. Everyone pays for rigidity. The social impact follows predictable lines. Wealthier districts protect themselves first. Higher walls. Better pumps. Backup power. Poorer areas absorb overflow. Basement apartments flood. Informal housing collapses. Heat kills where cooling is unavailable. Concrete doesn't distribute risk evenly. Concentrates it. In many cities, water systems become the breaking point. Pumps must run constantly. Power outages turn floods into disasters within minutes. During extreme heat, electricity demand spikes. Grids strain. When cooling fails, concrete buildings turn into heat traps. Hospitals prepare for surges. Mortality rises without headlines. Subsidence accelerates quietly. As land sinks, drainage gradients fail. Pipes reverse flow. Roads buckle. Rebuilding becomes endless. Each repair adds weight. Each layer pushes ground lower. The city fights gravity with concrete. Gravity always wins. Climate volatility magnifies every weakness. Storms are heavier. Heat waves last longer. Droughts dry soil. Then floods overwhelm it. Concrete cities have no buffer left. Systems designed for averages face extremes. Failure becomes sudden and cascading. At this stage, collapse stops being about infrastructure. It becomes about governance. Leaders face impossible trade-offs. Spend billions to protect shrinking zones, or retreat. Reinforce walls, or relocate communities. Raise taxes, or cut services. Every option angers someone. Delay becomes the default. Retreat is politically toxic. Concrete made expansion visible and rewarding. Retreat looks like defeat. So cities defend what they built, even when the cost exceeds the value. Sunk costs dictate future spending. The past controls the present. You can see this pattern repeating. Coastal defenses that grow higher every decade. Drainage systems rebuilt after every major storm. Heat plans activated every summer. Each response acknowledges failure without changing structure. Collapse stretches over years instead of days. Eventually, the system reaches a point where growth no longer offsets decay. New projects exist only to support old ones. Infrastructure feeds on itself. Debt rises. Credit ratings weaken. Investment slows. Maintenance is deferred again. Cities don't vanish. They thin out. Services degrade. Inequality sharpens. Safe zones shrink. Risk becomes normalized. Flood warnings become routine. Heat alerts become background noise. Collapse becomes part of daily life. This is the final stage of concrete dependency. Not spectacular ruin, but managed decline. A city that still stands, still functions, but only by pouring more resources into holding its shape against forces it can no longer absorb. Concrete was meant to create permanence. Instead, it creates fragility that must be constantly defended. Every year, every budget cycle, every storm. At some point, the math stops working. The cost of keeping rigidity alive exceeds what the city can produce. When that moment arrives, choices narrow fast. Protect less. Abandon more. shift risk onto those least able to carry it. Collapse doesn't ask for permission. It advances through maintenance schedules, insurance tables, bond markets, and emergency plans. By the time it's named, it's already locked in. If cities built on concrete are now spending their future just to preserve their past, then the question is no longer how to fix the damage, but whether it's even possible to step out of a system that turns every solution into another layer of the same problem. Concrete was supposed to make cities permanent, solid, predictable, a way to freeze progress in place. For decades it worked. Or at least, it looked like it did. The skylines rose. Roads spread. Flood barriers climbed higher. Each layer felt like control. Each project felt like an answer. Cities grew heavier, denser, more impressive. From above, everything looked finished. But permanence has a cost. Concrete doesn't age quietly. It demands attention. Maintenance schedules grow. Repair budgets expand. Emergency plans replace long-term thinking. What was once built to enable growth now exists just to hold ground. Cities begin to live inside their own structures. Water can only move where pipes allow it. Heat escapes only if power stays on. Soil no longer participates. Nature becomes an external threat instead of part of the system. Every deviation must be corrected with machinery, energy, and money. This is the moment when the illusion breaks. Not in a single disaster, but in repetition. Flood after flood. Heat wave after heat wave. Repair after repair. The question shifts from, how do we fix this? To, how long can we keep fixing it this way? Concrete is honest. It does exactly what it was designed to do. It resists change. It locks decisions into place. It turns short-term certainty into long-term obligation. When climate, water, and heat begin to move faster than structures can adapt, rigidity becomes risk. What makes this harder to face is that concrete is everywhere. It underpins housing targets, employment, finance, politics. Entire economies are built on pouring, maintaining, and defending it. Stepping away isn't just an engineering challenge. It's a social one, a financial one, a political one. Undoing concrete is slow, expensive, often invisible. You can't ribbon cut a restored floodplain. You can't photograph cooler nights. You can't measure avoided disasters the way you measure a bridge. Prevention doesn't look like progress. It looks like restraint. So cities keep choosing what they know. Another barrier. Another tunnel. Another reinforced slab. Each one feels safer than the uncertainty of change. Each one buys time at the cost of options. The result is a strange kind of modern city. More advanced than ever. More dependent than ever. Stronger on paper. Weaker in reality. A place where survival depends on continuous intervention, constant funding, and perfect coordination. Concrete didn't quietly destroy cities. It made them efficient, productive, and impressive, until those same qualities became liabilities. Until speed replaced balance. Until control replaced flexibility. Until permanence met a world that no longer holds still. The question now isn't whether concrete built modern cities. That part is settled. The question is whether cities built on a material that cannot adapt can survive in a century defined by constant change. And if the foundations beneath our cities were designed for a world that no longer exists, what happens when the ground, literal and political, keeps shifting, but the concrete never does?